Welcome to The Explainer. Okay, so if you're building AI agents, you already know how incredibly easy it is to get code generated. But what happens when those agents actually need to talk to each other? Well, today we're going to dive into the architectural skills that separate a simple script from a truly scalable, intelligent system.
So let's kick things off with a scenario that, well, it might feel a little too familiar if you've been in the trenches building AI agents. You've got these brilliant specialized agents, right? But the moment it's time for them to actually work together, everything just gets messy.
Your AI code generator? It feels like a superpower. Seriously, you're churning out hundreds of lines of code in minutes, refactoring on the fly. You feel totally unstoppable. But then you try to connect multiple agents and boom, everything breaks. This right here is the vibe coding trap. It's where your speed completely outpaces your structure.
So the solution here isn't to just code harder, it's to architect smarter. It's all about understanding these two fundamental architectural layers that you're probably missing, the very layers that turn a loose collection of agents into a cohesive, production-ready system.
Okay, let's really get into this. It's all about separating the rules of communication from the tools of orchestration. So, protocols. They're like HTTP for the internet. They are the absolute non-negotiable rules of the road for how agents talk. Then you have frameworks. Think of them like Fast API. They're the engines that actually build and manage the application using those protocols. So first up, protocols. You gotta think of these as the non-negotiable contracts that let your agents, even agents built by totally different teams or with different tech, understand each other perfectly.
A fantastic example of this is Anthropic's Model Context Protocol, or MCP. Just think for a second about the pain of building a custom, brittle integration for every single new tool or data source. It's a nightmare. Well, MCP is a total game changer because it just gets rid of that, creating one standard way for agents to discover and use any tool automatically.
And this just brilliantly shows its power. A company like Block built their Goose agent using MCP. So now their engineers can just ask the agent to refactor code, and the product teams can ask it to generate documentation, all without the dev team having to rebuild tool integrations for every single new thing.
But what happens when agents build with completely different technologies have to work together? Maybe your fraud agent is built with LangChain, but your support agent uses CrewAI. Well, that's exactly where Google's agent-to-agent protocol, or A2A, comes into play.
Now, what's really cool here is how A2A makes collaboration official. It gives agents these agent cards to advertise what they can do, a standard way to manage the lifecycle of a task, and even gives you real-time updates using server-sent events. It's kind of like the handshake and the project plan all rolled into one, and it's all secured with standards like JWT and OIDC for authentication.
All right, let's shift gears to frameworks and see how this all builds up. If protocols are the universal language, then frameworks are the project managers that direct the conversation, manage the entire workflow, and handle all the heavy lifting.
And look, you've got several powerful options, each with a pretty different philosophy. So are you building a really complex, stateful workflow where you need super precise control? LangGraph is probably your go-to. Need something that's production ready right out of the box? You should check out Strands. Or maybe you're just prototyping quickly with role-based agents? CrewAI is fantastic for that. And of course, for anyone deep in the Google Cloud ecosystem, the ADK is a natural fit. The key is you've got to match the framework to your project's specific needs.
So why does any of this actually matter? Because without these layers, without the protocols and the frameworks, things go wrong. And they go wrong in very visible and very expensive ways.
Let's take a look at a healthcare example. A hospital system set up a chain of agents to process clinical documents. It was super simple. One agent for transcription, one for medical coding, and a final one to integrate everything into the patient records.
And the system worked perfectly for weeks. But then a simple upgrade to the medical coding agent, it slightly changed its output format. And because the next agent in the chain had no way to validate that change, it just blindly wrote incorrect data to over 1,200 patient records. A disaster.
So, here's the crucial point. The failure wasn't the model upgrade itself. The failure was the complete lack of a communication contract. A protocol like MCP would have enforced schema validation between those agents and would have prevented this catastrophic error entirely. But on the flip side, when you get this architecture right, you see massive gains. Look at this example from financial services. Before, their agents were just polling a shared database, which took up to 10 seconds per transaction. But after they implemented protocols and a framework,
Real-time notifications cut that time by 60%.
And these are not just some theoretical wins. Major firms, like the investment giant PIMCO, are seeing real, measurable financial returns. They saw a 15% improvement in investment returns just by using MCP. It ensured their data analysis agents could reliably and quickly get to all these diverse financial data streams, which led to way more accurate and timely decisions.
But without proper task management from a framework, even a tiny error can be devastating. In this case, a triage agent hit a simple network error. Because there was no standard for handling failure or managing the task state, the query just sat there, in limbo, for 47 minutes, until of course the customer gave up and canceled their contract.
And this brings us to the single most important takeaway from our whole explainer today. In this age of AI-assisted coding, your value, it isn't just in writing the code anymore.
Your AI assistant is phenomenal. It can write boilerplate code, it can implement patterns you describe, it can refactor files. It's amazing, but it absolutely cannot make these critical architectural decisions for you. It can't choose the right protocol, design failure recovery, or plan your security model. That's your job.
That's the real skill that separates a hobbyist from a professional agentic AI developer. It's knowing when you're just building the wrong thing really efficiently versus architecting the right, resilient, and scalable system from the very beginning.
And that's the question you really need to consider the next time you kick off a new AI agent project. Because with the right architecture, you can finally move from simply coding agents to truly engineering intelligent systems.